Hello, Algebra 2 students. So this video is some extra help from our Khan Academy lesson about rewriting exponential expressions. So these are kind of tricky because each one is a little bit different. So what I'm going to do is I'm just going to go through 12 examples. So 12 problems that deal with rewriting exponential expressions, and hopefully with these 12 examples I'll answer any questions you have. So this first one is, we're going to do 0.9 to the 60x equals a to the x, and we're looking to find a. Now, if you're watching this video, please write these down on a piece of paper and try these with me. Take notes so you can learn by doing, not just by watching. So we're trying to find a, which means that a needs to have the same base as this 0.9. So what can this a be to match this one? Now I know that I can do a power to a power. When you have a power to a power, you multiply. So that's what happened here. So let's reverse that, go backwards with that property and say this is 0.9 to the 60th power, all raised to the x power. Now remember, power to power, you multiply, so 60 times x is 60x. So we went backwards, we reversed that power to power rule to break it down to look like this form of a to the x. So now both a is raised to the x, and this 0.9 to the 60th is also raised to the x, so that's the same base. So I can say now that a is 0.9 to the 60th power, and then that would be your answer. You're done. Let's look at another one like this. All right. Second example, 1.44 to the negative 1.2x. We're rewriting it as that a to the x, and we're trying to find a, just like the last example here. So same thing, I want to make this a to be a base of 1.44, raising it to the x power. So I know that a power to a power you multiply, so I'm going to reverse that property and say that 1.44 to the negative 1.2 and raise that to the x. Power to power multiply, so that gives you what you started with. And remember, we're looking for it to be to the a to the x, and now they're both raised to the x, so now I can say that a is this 1.44 to the negative 1.2. And that's your final answer there. All right, let's try another one. Remember, you can pause the video at any time and try these on your own as well. Same thing, we're still finding a. So you would do the power to power rule. So 6 over 17, I'm going to take that to the 9th power and raise that whole thing to the x power. Looking for a. Now they're both bases raised to the x, so I can just now say that a is equal to 6/17 to the 9th power. And then that would be your answer right there. All right, moving on, let's do another one. Okay, it's a little more complicated now. I have 5 to the negative 4x plus 7 over 125 to the x. And we want to rewrite that as a base of 5 to raised to an exponent, and they're calling the exponent f of x. You could easily just call that x, same thing. But what we're looking to do is to take this and simplify it down to just the base of 5, and then whatever that exponent is, that's going to be your answer, because we're trying to find the exponent. We're trying to find the f of x there. Okay. So, first of all, I want these bases to be the same. Right now I have the base of 5 and a base of 125. So I'm going to rewrite that base of 125 so it's a base of 5. So I'm going to keep that numerator the same. And then I'm going to take this 125 and rewrite it so it has a base of 3. So that would be 5 to the third. 5 times 5 times 5 is 125. And if you needed to use your calculator, you could easily do that. You know you're working in a base of 5, so you would just do 5 times 5 times 5 until you reach that number. But then that all has to be raised to the x power. All right, so now I have the same basis, so now I can use my exponent rules. This is division. I'm dividing bases. When you're dividing bases, you subtract exponents. So I can rewrite that as a single base, just a base of 5, since they're like bases. And then I'm going to say negative 4x plus 3 minus this exponent. Remember, power to power multiply. So this is the same thing as 5 to the 3x. 3 times x is 3x. So I'm going to take this, since I'm dividing, I'm going to subtract. I'm going to take the bottom exponent, subtract that. Okay? And then I can just simplify by combining my like terms. So this is 5 to the negative 7x plus 7. So we did it. We got it simplified down to a base of 5 here. Let me scoop this up a little bit. Base of 5 here, and then the exponent is what we're looking for. So this is your f of x right here. And then that's your answer. All right, let's look at another one like this. This one's a little more tricky. Okay, now example number 5. Remember, we're going to do 12 of these. Lots of examples. Learning by practice. So we're going to rewrite it with a base of 3 to an exponent. They're calling the exponent f of x. But you could call it x if you want. Don't let that confuse you. But we're looking for the exponent. So we're working to simplify down to a base of 3. This is already a base of 3. This is not, so I need to change this to a base of 3. I'll just bring down this first one. So base of 3. So 3 to the what equals 27. Well, that would be 3 to the third. 3 times 3 times 3 is 27. So I changed that 27 to 3 to the third because we're looking for a base of 3 here. And then raise that to the x. Got to bring down that exponent. And power to power, you multiply, so you can simplify that down to 3. 3 times x is 3x, so 3 to the 3x there. And now when we're multiplying, we add exponents. So we're going to add these exponents to simplify it down. Base of 3 and then add your exponents. Combine your like terms. 5x plus 3x is 8x plus 3. So that is your f of x there. Remember, we're trying to simplify it to base of 3. And then the exponent is your f of x. So f of x equals 8x plus 3. And that's your final answer. All right, let's try one more like this with that f of x there. Example number 6. Write this down, try it on your own, pause the video, try it on your own. Okay, so this time your base is a fraction, but don't let that scare you. You're still gonna do the same process, even if it's a fraction. So we're looking for our base to be 1/7. So this one's already 1/7, so that's good to go. But we need to change this 1/49 to 1/7. So 1/7 squared would be the same as 1/49. Let's look at how that works out. That would be 1/7 times 1/7. Multiply it by itself. That would be 1/49. So that's how I got that. So you're kind of thinking backwards on these, which can be kind of confusing, but the more you practice it, the better you'll become at it. So 1/7 squared is the same as 1/49, but we did that because we need that base to be 1/7 here. And then we're going to raise that to the x power. You bring down that exponent of x. All right. And then this is good, so we'll just bring that down. Okay. Then we're going to simplify further. So I know that this is a power to a power. So I can just say that's 1/7 to the 2x power. Bring this down. Okay, same base, we're multiplying. The rule is when you're multiplying, you add exponents. So we're gonna add these two exponents together. That's 2x plus 6x plus 11. Combine your like terms. That's 1/7 to the 8x plus 11 there. Okay. And then, so that's what we were trying to do. You were done. So you got your base is the same, the 1/7 and the 1/7 here. And then your exponent is that f of x. So here's your answer. F of x equals 8x plus 11. All right. Okay, moving on to a little bit different problem. Example number 7. Okay, 3 to the x. We're going to rewrite that as a to the 5x, and we're trying to find a. All right, so we're trying to get this to be raised to the 5x. So I'm going to keep my base of 3. And I want this 3 to the x to become the 5x. So I have to think, how can I change an x to a 5x? So what I can do is I can say 3 to the 1/5. So think that through with me. If I do 1/5 times 5x, let's see what happens. Because remember, power to power, you can multiply those. So 1/5 times 5x, let's say over 1, those 5's cancel out and you're just left with x. So 1/5 times 5x is the same as just x. So I'm allowed to do that. I'm allowed to say 3 to the x is the same as 3 to the 1/5 to the 5x. And the reason I knew to do 1/5 because of that 5. So I just took the reciprocal of that 5. The reciprocal of 5 is 1/5. So that's where that came from. So now look, they're both raised to the 5x. So I can say that A equals 3 to the 1/5. And then that's your answer, 3 to the 1/5. All right, let's look at another one like that. Okay. Okay, same thing, except for now I have a fraction as a base. Don't worry, still do it the same way. Still finding A. Okay. So I'm going to take the 7/3. That's my base. I'm going to start with that there. And I want to raise it to 2x, okay? So what times 2 would just give me x? Or what times 2x would just give me x? That would be 1/2, the reciprocal. Remember we talked about taking the reciprocal, because 1/2 times 2 is 1. It cancels out. So then now I have the 2x and the 2x that I was looking for here. And so I can now say that A is equal to all of this. A is equal to 7/3 to the 1/2 power. And then that's your answer there. All right. Let's do one more like that. Example 9 here. Okay, so now the exponent we're looking for is a fraction. So we're going to have to think backwards even more now. So I need to know what times x/12 would just give me x. What is the reciprocal of that? What is the reciprocal of 1/12? Reciprocal of 1/12 is 12. So I'm going to do that. I'm going to do 2 times 12. Remember, I'm trying to get that exponent, x/12. Let's test out my theory to see if this worked. I'm just going to do a little side note here. 12 times x/12. Well, I can put that over 1. Those cancel out, and I'm just left with x. So that worked out. So I just took the reciprocal here. Reciprocal of 1/12 is 12. And now I know that A is 2 to the 12th. All right. Let's try another one. Okay, still finding A here. So we're rewriting this expression here as A times 3 to the x. So I want my base to be 3, which we're already good here. So what I need to do, since I already have my base of 3 here, I just need to simplify it down to a single base of 3. So I'm going to use my exponent properties. This is pretty simplified. X, or 3 to the x, really nothing you can do with that. So I'm just going to bring that down. Minus. Now I have an exponent here of x minus 2. So subtracting exponents, to undo that, you could make it division. So this would be the base of 3 to the x divided by 3 to the 2. When you're dividing, you subtract exponents. So because I saw that subtraction, I'm going to go backwards and I'm going to say, okay, so that becomes a division problem. Dividing like bases, subtract exponents. So I saw those exponents being subtracted and made it into division. So you're really just reworking it until you get it simplified. So now what I can see is, well, 3 squared, that's 9. So I can rewrite that there. Okay. And now I see that I have here a 3 to the x here and a 3 to the x here. So that is my common factor. I can factor that out. And then I'm left with 1 minus, took out that 3 to the x, 1 over 9. Factored out a 3 to the x because they both had a 3 to the x. Pull it out, divide everything by 3 to the x, and you get that. Bring that down. Now I need to do 1 minus 1/9. So I can say 9 over 9 minus 1/9 is 8 over 9. I don't know if you can see that. There you go. All right, so I had 1 minus 1/9. Change the 1 to 9 over 9, and you get 8 over 9 there. So now look back, that's what we were trying to find here. A times 3 to the x. So that A is our 8 over 9. A is 8 over 9. All right, let's try a couple more like that, and then that will be the end of this video. Okay, number 11, example 11 here. Sorry this is so long, but these are complicated, so I just wanted to give you lots of examples. So, depending on what you encounter when you're doing your practice, you'd be able to figure it out here. Okay, next example. So we're working in base of 5. We're already in base of 5, so that's good. So now I'm just trying to break it down as much as I can. So I see here that my exponent is x plus 3. So when you're adding exponents, that means it was originally multiplication. When you're multiplying like bases, you add exponents. So I'm going to go backwards. Bring this down. That's already as simple can be here. So I'm going to say this is 5x times 5 to the third. Remember, when you multiply like bases, you add exponents. That's where that x plus 3 came from. So we just kind of worked backwards there. Okay, so this right here became this. Now I can see that I have this 5 to the third, 5 times 5 times 5. Simplify that down to 125. 5 times 5 times 5 is 125. And then I notice that I have a common factor of 5 to the x, so I'm going to pull that out here. Factor out of 5 to the x. And then 5 to the x divided by 5 to the x is 1. That pulls out as 1. And then I'm just left with that 125 there. Okay, and then you just add 1 plus 125 is 126. Now you have what you wanted, that 5 to the x times a times a number, so that a is 126. Ta-da! All right, one more. So let's do another one like this, but use a fraction instead. Fraction as the base. Don't be intimidated by fractions. You still work the problem the same. Okay. Still finding it here. So we're rewriting it with a base of 1/8. We're good to go there. So this is as simple can be here. So I'll just bring that down. And then remember, subtraction means that it was division originally. So plus 1/8 to the x divided by 1/8 squared. So like bases, when you're dividing, it's subtraction. So we went backwards there. Took the subtraction, changed it to division. And then I can simplify this 1/8 squared. That's 1/8 times 1/8, which is 1 over 64. So I'm going to change this 1/8 squared to 1 over 64. Rewrite everything else. 1 over 64. Okay. Now I can work this. I can use my keep, change, flip rule here. I'll bring this down. Keep the top. Change the division to multiplication, and then flip 1 over 64 becomes 64 over 1, or just 64. I don't really need to put it over 1. So all of this became this. Now I can look at this and see I have the common factor of 1/8 to the x. So I'm going to pull that out, factor that out, 1/8 to the x, and then you're left with 1 plus, pull that out, 64. You pull it out for 1, so 1 times 64 is 64 there. Okay, and then just add 1 plus 64, that's 65. So, remember what I wanted. I wanted 1/8 to the x. I wanted to simplify it down to 1/8 to the x, and I did that, 1/8 to the x here, times 65, so that a is 65. And that's your answer. Okay, I hope this was helpful. I know this is a really tricky lesson. And I'm sorry this video is so long, but like I said, I wanted to give you lots of examples so you can get some practice before you try it on your own. All right, that's it. Have a great day.